was steam and water vapor. I see it. Dude, Cody, wake up. Why are you in my house?
It doesn't matter, our physics project is due today.
But now, what exactly is momentum? Well, I like to define momentum as the equivalent of the product of the mass of the object multiplied by the velocity of that object. Or you could say, in order to have momentum, an object needs to have both mass and velocity. So, let's add units to these. P equals mv. P and v have respective vectors, which means that those numbers have magnitude and direction. They're vectors. The units, kilogram times meter per second for P, obviously because kilogram for mass times the meter per second for velocity. Or P is a Newton times a second. So P equals mv, mv equals P. You could say that this equation is your most valuable player in your equations of physics. Moving on. We've got momentum covered, but you can apply it in different ways. One of them is the conservation of momentum law, where P1 equals P2. Now, you can only apply this in different scenarios. The system has to be closed. No forces can act upon the system. But that doesn't mean you can't break it into their respective masses and velocities. mv initial, or before the collision, just before the collision, equals mv final. Final, after the collision, just after the collision. Now, you can apply these in lots of different ways, but here are my favorites. One, where two things become one, like in a car crash. Or, where one thing becomes two, like your 4th of July fireworks. Or, let's say you have two things bounce off of each other, but they still are their separate identities. That's where you'd use these two. All four of them are very handy uses of them, but there's still lots of other things that you can talk about with that. So let's talk about these different things. I mean, there are many different uses of it.
You're boring! You're boring! Okay, kids, to sum it all up, momentum right before a collision is the same right after a collision.
Now we're going to do some conservation of momentum experiments you can do at home. Here we have a small ball and a big ball. We're going to drop them at the same time with the small ball on top. And when they hit the ground, the small ball is going to shoot way up. Now let's try this out. Here we have Mr. Golf Ball. He's smiling, but he won't be for long, because we're going to do the same thing with a much smaller mass on top. Here we go. So here's a recap. The basketball hits the ground. There's a little space between the golf ball and the basketball. The basketball comes up, colliding with the golf ball. Since the basketball has a greater mass, the golf ball shoots way up because it must have a higher velocity to conserve momentum. So to sum it up, momentum right before the collision and right after the collision is the same. Momentum is conserved.